Hi, everyone. I'd like to welcome you to our webinar on organic swine production by Dr. Yuzhi Li of the University of Minnesota. I'm your host, Alice Formiga of eOrganic. The presentation will last approximately 45 minutes to an hour, and then we'll have 30 minutes for audience questions. So today, I'm very pleased to welcome back Dr. Li. This is our second webinar on organic swine production. She presented one last year on reducing feed costs, and today she's going to talk about challenges and opportunities in organic pig production and summarize the result of her NIFA OREI funded research project on this topic. So with that, I'm just going to hand over the presentation to you, Yuzhi.
Thank you very much, Alice, for the introduction. And everyone, hello from East to West Coast. Thank you for being here today to join us the webinar. So at the University of Minnesota, we have been conducting research on organic swine production. The overarching goal of our research is to identify challenges in organic pig production and find ways to deal with them. So I put this presentation together to share what we learned over the years. So before diving into our research, let's look at the big picture of organic market. So according to a USDA survey, the organic sector is keep growing over the years. So the total sale of the commodity jumped from $7.6 billion in 2016 to $11.2 billion in 2021. So the growth is not evenly spread among different commodity. And here you can see the market share for crops, eggs and milk, and livestock basically livestock and poultry. That means meat. The market share varies from year to year. But one thing I want to point out is the meat section, which is in red on this chart, keep growing from 16% in 2016 to 20% in 2021. But that's mainly because of poultry. So the pig sector actually does not share the same growth. So let's look at the organic pig production. Basically, the number of organic pig farms decreased from about 150 farms in 2016 to about 100 farms in 2021. And the pig inventory basically remains flat over the years at about 20,000 organic pigs. And the number of pigs sold in 21 was about 25,000, which is more than 2016, but is lower than 2019. So the revenue reflect the number of pigs sold. So basically, it's at about 7.7 million in 21. So when we look at the organic pig production closer, and we see the organic pigs basically are produced in Iowa and Wisconsin. So these two states produce about 50% of total organic pigs in the country. But you can see a great decrease in Wisconsin over the recent years. And on the other hand, states like Pennsylvania, Michigan, and Minnesota are on the rise. Why we do not see growth in organic pig production? I think the high standard for organic pig production pros challenge. For example, the requirement of bedding with outdoor access, plus now synthetic dewormers really put the parasite control difficult. And also feed and the bedding cost is a major challenge for farmers to keep the production profitable. And another thing is the now confinement housing result in a higher pig mortality. So here's the picture of organic farms. So when you look at organic pig production, you look at farms like this. And in this picture, these are our facility here in Morris. And the top left, this is the gestating cells, group house, unbedded barn, unbedded floors. And this is the farrowing barn with outdoor access, pigs and their piglets. And this is the nursery barn, pigs unbedded floor. And this is the finishing pigs. So you can see all pigs are housed on bedded floors, and all of them are now treated with any antibiotics or dewormers from the third trimester of gestation, actually. So with that high standard, we face the challenges. And over the years, we try to find what really the challenges farmers face at the farm level. So we visited organic pig farms in 5 states. All the 5 states had more than 1,000 pigs. So including Minnesota, Iowa, Wisconsin, Michigan, and Pennsylvania. We also conducted a survey and August focus group meetings. And through those activity, basically we gathered the challenge identified by farmers mainly in 3 areas. So the first area is animal health, and parasites is on the top of the list. And the others will be how to keep pigs healthy without using antibiotics. And the second area is markets and supplies. And this is always the biggest challenge. Like, where can I find the meat processors? And where can I sell my organic pigs? And where can I source alternative feed ingredients, especially proteins? But these are kind of, related to economics, market price, even policy, and largely out of our control. The third area is production cost and efficiency. Basically, organic feed and beddings are very expensive, and also initial setup and the cost versus returns, and also probably the certification fee and also annual inspection fee. And another thing is piglet mortality. I talk about now confinement is associated with uh, piglet crashing by the cell. So piglet mortality usually is higher. So our research basically focus on parasites, feed and bedding cost, and mortality. So let's look at closely to the first challenge, which is pig parasites control. So to understand the parasites, to develop parasites control strategy, first of all, we need to know what kind of parasites are on the organic pig farm and how bad they are infected. So we tested the parasite prevalence on 9 organic farms across 4 states, Iowa, Minnesota, Wisconsin, and Pennsylvania. So we collected fecal samples from 3 age group of pigs, including breeding sows, growing pigs, and finishing pigs. We examined 3 major parasite species, including Osphagostognum, Ascaris, and Chucuris. So here's the results. This is the parasite prevalence in breeding cells. So among the 6 farms that housed uh, cells, 2 farms didn't have any parasites, which means it's possible to keep cells parasite free. And the other 4 farms, 3 of them had that's nodular worms. And I want you to pay attention to these 3 farms because we'll see the same parasites on the farm in the younger pigs. So farms 3, 7, and 8, they all had sulfur totem in the cells. So this basically, this slide tells us, first of all, some farms, they are parasite-free in the sow herd. And secondly, the nodular worm is the major parasite in the sow herd. And this is the growth finishing pigs. And we see all the farms, the 6 farms, they had growing pigs, and all the farms were infected with at least one kind of parasite. And you see the 2 farms had the nodular worms. So I do not use that term; it's too hard for me to pronounce. So I call it nodular worms. So the 2 farms has a nodular worms, and these 2 farms also had nodular worms in their cells. So you can see if the cells had parasites, their younger, their offsprings will have the same parasite. And another thing is asparagus, that's the large roundworms, are very widespread in the growing pigs. And also treachery is also widespread. And this is the parasite prevalence in finishing pigs. Again, we see the nodular worms in farm 3 because the sow had it and the growing pigs had it. And again, we see the nodular worms in farm 7 because the sow had it. So another thing you see is asparagus. The blue bars are very popular among the 8 farms that had finishing pigs. 7 had asparagus. And the infection rate is pretty high. That's the percentage of pigs infected with this parasite. So at least 45% to even 100% of pigs were infected by at least one kind of parasite. So we also tested co-infection, which means whether pig can be infected by all 3 species or 2. And this chart just tells that. So the blue bars means they are not infected by any. And the next one, the dark green means by one species, and the purple means 2, and the black means 3. So in sow herd cross board, on average, 80% of cells were not infected by parasites at all. Only about 20% were infected by one species. But if you look at the finishing pigs, it's the opposite. Less than 20% were not infected. So which means more than 80% of pigs were infected by parasite, but majority of them were only infected by one species. So cross-board, less than 5% of pigs were infected by 3 species. So the co-infection is very low. So kind of summary about parasite prevalence on these 9 farms. So by age group, basically we see it's kind of relatively low in the sow herd. About 20% of sow were infected. And also remember, it's possible to keep parasites free in sow herd. And another thing is the nodular worms is a major uh, parasite in the sow herd. And this is because the nodular worm is usually cannot stimulate immunity, so pigs cannot really get rid of it. But for the other 2 parasites, asparagus and treachery, usually pigs can generate a better immunity after getting infected. As they get older, they can get rid of it. So in the finishing pigs, we see every farm were infected. So about 80% of all the finishing pigs we sampled were infected, and they were infected by the large roundworms. When you look at the farm, basically all 9 farms were infected by at least one parasite. And 8 out of 9, they were infected by asparagus. So asparagus is the major dominant species in growth finishing pigs. And that's the challenge we try to tackle in our research. So at the University of Minnesota, we conducted research, try to develop management strategy to control parasites. So this research basically asks three questions. What production stage to target for parasite control? Sows, nursery pigs, or growing pigs, or finishing pigs. The second thing is, does sex of a pig matter, which means whether a barrels were infected more often than gills or vice versa. And the last one is how parasite infection can influence growth, carcass trait, or liver quality. So we collected fecal samples from about 300 cells, including gestating cells, nursery pigs, grower pigs, and finisher pigs. And here I want to you note that nursery pigs were at 6 weeks of age. We also collected data on growth performance and the carcass trait. And finally, after slaughter, we examined the milky spot on the liver and the presence of worms in the gut. And here's the parasite infection. So we only find one species of parasite, which is ascaris, but we didn't find any ascaris or any parasite in the sow herd or the nursery pigs. We find 45% of growing pigs were infected by ascaris, and we find 74% of finishing pigs were infected. So you can see compared to finishing pigs, grower pigs were kind of less infected. And this part of chart is the infection load, which means how many parasite eggs per gram of fecal samples had. So again, now in cells and nursery pigs, but we see much lower load in growing pigs than finishing pigs. So these data make us feel like probably growing phase is the best production stage to target for parasite control because the infection rate and the infection load are lower than finishing pigs. And then the second question, whether sex matters. And the answer is no. Both barrels and gills are infected similarly in terms of the percentage of pigs infected or the infection load. And then finally, how that affected parasite infection affect growth performance. So for pigs not infected versus pigs infected, they had similar final weight, they had similar average daily gain and carcass weight, dressing percentage, and back thickness. So basically, parasite infection, and in this case, is asparagus, didn't affect our pig's performance. So when looking at the milky spot on the liver, we examined 32 pigs, and all of them had milky spots. Some had fewer, some had more. And among the 32 pigs, 25 had worms in the gut. And when the liver had more than 10, milky spot, they usually lost value and cannot be sold for human consumption. So 24 of those had too many milky spots, couldn't sold for human consumption, which account as 75% of total number of pigs examined. So all these 42 pigs cannot sold, their liver cannot sold, they all had worms in the gut. So if we see a worm in the gut, probably the liver of that pig will lose value. So kind of summary of our research here, basically we only find asparagus is the parasites here, and growth finishing pigs are heavily infected. We said 45% of growing pigs and 74% of finishing pigs were infected. And to us, the economic loss is really the liver contamination. So 75% of the liver basically examined, loss of value. which match the infection rate in finishing pigs because we found 74% of finishing pigs were infected. So we didn't find any parasite eggs in our nursery pigs. And first thing, probably because our cells are parasite free because we deworm them by the third trimester of gestation. So the pigs born to clean cells. Clean means they are parasite free. And secondly, for asparagus, we are not sure whether nursery pigs were infected or not because they are too young to shed parasite eggs. It takes 6 to 8 weeks for the eggs to hatch, to mature, to shed eggs in from the pig feces. So we collect the fecal samples when pigs were only 6 weeks of old, 6 weeks old. So a few thoughts about parasite control strategy. First of all, it's possible to keep cells parasite free. And not only on our farm, we also see this on commercial farms. And secondly, for nursery pigs, you know, if your cells are parasite free, you probably do not see any parasites carried by other cells like the nodular uh, worms. And then because nursery pigs, they're young and they're very vulnerable to parasite infection. So if they are good and not infected, probably you do not see a lot of loss in your pig production. So the second thing I think I always emphasize that keep your barns clean between groups. Doesn't means clean doesn't means you know the clean we talk about the house we live, but to break the parasite cycle. So if you clean the barns between groups, and that can help with break the cycle. So growth finishing pigs is the tough one. And I either on our farm or on commercial farms, I didn't see any farms without parasites in growth finishing pigs. So I believe we need to deworm growth finishing pigs. And the question is, first of all, for organic pig production, you have to use organic approved product to deworm. And another thing is you probably try to minimize the time number of deworming. You don't want to deworm all the time. And I'm thinking if you can only deworm once, maybe during the growing phase, at about 15 weeks of age is the best stage, production stage for deworming, because based on our data, the infection rate and the load is lower than finishing pigs. And you may say, should I deworm in growing in nursery pigs? I think if you deworm in nursery pigs, you probably will still see a parasite infection in finishing pigs. And then during the finishing stage, and then you probably will see the loss of liver value. So let's look at the second challenge, pig mortality. We collected the data here in Morris on pig mortality over the years, and these data basically are from our 10 years data. So we see clearly seasonal effect, higher mortality during the summer, uh, lower mortality during the winter, but in general, the peak mortality range from 20% to 28%, which is much higher than conventional pig production. In conventional pig production, you probably see about 10 to 12%. So we are almost double. And in our case, we have a heating system in the farrowing barn, but we don't have any cooling system in the barn. So heat stress is an issue for us. So this basically emphasizes the thermal environment is important to pig mortality plus the now confinement. And second thing we see is the parity effect. And clearly we see as pigs get older, the sows get older, we see mortality increase. So the top line is the very top is born alive, and the second top line, the red one, is number of pigs weaned per liter, and then the two blue lines, one is stillbirths and the other one is the number dead. So you can see after 34, the liter wean is reduced dramatically. And this is the pig mortality basically tells the same story. Before 33, parity 1 and 2, you see uh, mortality is lower than 20%. But once go to parity 3 and up to parity 4, it from parity 4, the mortality climb up to 25% or higher. So if farmers want to keep cells longer than 33, they have to be very selective. Otherwise, they will see higher pig mortality. So this chart just show you the critical window for piglet management. So basically, 50% of the total loss occurred during the first 3 days, and with day one loss most. So kind of summary about our research on pig mortality here. So in general, our pig mortality here is a range from 20 to 28%, which is very common in organic pig production. So if you ask organic pig farmers, they probably see that number. For individual group, they may see lower, but on average, they probably see uh, that high mortality. And 50% of the total mortality occurred within the first 3 days, with the first day lost most. And then parity effect. I think a lot of farmers may not realize the parity effect, but as I said, our data collected over 10 years, we show that consistently. So parity effect definitely is an issue need to be considered. And finally, seasonal effect. In our case, summer is worse, or winter is better than summer. But if you farrow outside during cold summer, or your barn is not insulated, warm, heated, you may see a different story. But regardless, thermal environment plays a role there. So the last one, feed and bedding cost. The higher organic feed cost is associated with the high price of organic corn because the pigs, consume a lot of corn. 70% of their feed is corn. So this chart basically shows the price of organic and the conventional corn price. The top blue is the organic corn price. The gray one is a conventional corn price. And the bottom blue is the ratio of organic to conventional. So basically you see the organic always about the price of organic corn is about 2 to 3 times of conventional corn. So our solution is to grow winter hybrid to replace the expensive organic corn. So rye grain can be used as feed ingredient, and the rye straw can be used for bedding. So bedding is expensive as well. You don't have purchase straw. And plus the small grain hybrid can bring other benefit to the environment and to the crop rotation to prevent plant disease or pesticide. And also in terms of environment benefit, because it's winter, right, it can prevent soil erosion and the runoff in the spring. So this table basically shows the results of our study. The left two columns show the performance of pigs. So basically, we replace 50% of corn in the diet with rye we produced. And you can see the feed intake, the total feed consumed by the two groups is similar. To say pigs on the right diet consumed 13 pounds over that 13 weeks of growing finishing period. So we want pigs eat more, because if they eat more, they grow more, right? But when they eat more, they also increase the feed cost. Even they eat 13 pounds more than the control diet, we still save $10 per pig on feed just because rye is cheaper. And in terms of bedding, we see pigs bedded with rye straw produced here. They use less bedding than pigs use of wheat straw we purchased. Probably because the rye wheat can absorb water better. So with that less use of bedding, we also save $4 per pig. So put feed and bedding together, we save $14 per pig. But on the other hand, pig produced from the rye group had lighter carcass weight. The final body weight was similar, but they are lighter for carcass weight because the dressing percentage is a little bit lower compared to the control pigs. So with that, we lost $8 per pig. So $14 minus $8, we still make save $6 per pig. And then this table tells the how much money or net return we may have if we grow rye ourselves. And the the yield actually is from our research here. We grow rye for 2 years, and this is the average of rye grain we got, and the straw we harvested. So the price basically is the market price. So with that, we estimated that per acre, the crop value is $727. And these are the production cost. So use the data from FinBin, managed by University of Minnesota. The total cost is $664. So use the total crop value minus the cost, we got a net return $63. It's not a lot of money, but it's a positive number. And then we look at the crop value over 6 years from 2018 to 2024. And we did our study between 22 and 23. So that's the number from the first page, from the previous page. You see all these. And then the basically the crop value you see varies from 500 all the way to 700. This is because um, the rye price changes over the years. And then the net return, the crop net return, basically the crop value minus production cost. And that varies from negative even $56 per acre to positive $113. So if you grow rye only, you may lose money some years when the cost is very high and the crop price is low. But when you use rye for organic pigs, we see the swine saving, for our study, we save $6 per pig. But over the years, you see that varies from $5 to $11 per pig. And then each acre of rye produced can feed 23 pigs. So that gave us the swine saving per acre from $125 to $257. So, for crop production, you may lose money or you may make money. But if you use rye produced for organic pigs, you probably see positive number. So when they put the pig saving with crop net return together, the total saving crop and the swine saving varies from $129 to $270 per acre. So we also did a sensitivity analysis to see if, as a crop farmer, how much yield you should achieve or how much the market price rye should be to be profitable. And from this sensitivity analysis, we can see the yield should be minimum of 80 bushels per acre, and the price should be at least $6 per bushel. And then you see kind of black, the profit rather than deficit. But clearly, the profitability is very sensitive to the rye price. So kind of summary on uh, reducing cost. So if we grow rye and replace rye, 50% corn with rye produce and using rye straw as bedding, we see a saving of $14 per pig of feed and bedding cost. And then if we integrated crop production with swine production, we see the total combined return range from 129 to $270 per acre. So for crop farmers to be profitability by growing rye, the minimum rye yield should be 80 bushel per acre, and the minimum rye price should be $6 per bushel. So kind of take-home message, organic crop production is kind of flat or declining, basically because of high production cost and the inefficiency. So we see self-sufficient in feed and bedding is an opportunity and which can control costs and improve net returns. Finally, the in terms of strategy for improvement, parasites control and reducing pig mortality is the area we should be working on. I think with that, I'd like to acknowledge our funding agency. Over the years, we received funding from OREI and organic transition programs. And I also like to thank our collaborators and partners, including organic farmers and stakeholders, and our collaborator at Rhode Island Institute, Kutztown University, Michigan State University, and our research team at the University of Minnesota. With that, I would like to thank you for your attention. And yeah, I'd like to open the discussion with you all.
Okay, great. We do have a question. So, what would be the differences between organic pig farming and pasture-raised pig farming?
That's, Thank you for the question. So organic pig farming, basically you have to meet all the organic standard. So the difference between pasture and organic, first of all, is pasture pork does not require organic feed and bedding. And also pasture pork, basically you can use antibiotics and you can use synthesized dewormers, but organic pigs you cannot. But on the other hand, for organic pigs, it's not required for pasture access. So which means you do not have to put your pigs on pasture. Although organic pigs require outdoor access, but doesn't mean they need to access to pasture.
Okay, we have another question. Were any of the pigs studied infected with PRRS? Were any of them vaccinated for PRRS prior to the study?
First, right? So no, our pigs never, we don't have PRRS in Morris, so we are very fortunate. And I know some organic farmers, they are infected by birds. So organic pigs are also pigs. They can be infected by, you know, any virus or bacteria or disease other pigs share. But for our pigs and all the pigs we studied in this presentation, none of them were infected, at least during the time when we collect the data.
Okay, when you were discussing parasites, it seems like the downside of a parasite load was just condemnation of the liver. What is the cost benefit of an aggressive dewormer regime compared to just writing off selling the liver for human consumption?
That's a good question. I think for us, it's not a big deal. Yeah, if you think liver, you don't care, you don't sell it. Uh, but I do see some farmers, organic farmers, and even some farmers, they raise pasture pork. They have problem with parasite infection. Basically, they see their pigs died. They see their pigs didn't grow sick, and they have to remove the pig from the organic herd because when they're sick, if you treat them with, antibiotics or whatever, they're not organic pigs anymore. So if your pigs are infected young, and they may be vulnerable to parasite infection, and you may lose them either as organic pigs or even just as a pig. They may die. So when they are young, they can be very sick, get diarrhea, and do not eat well. The inflammation caused by parasite infection and reduce their immunity to other sickness. And they may not, if they do not digest well, they cannot absorb enough nutrient. They may not grow. Yeah, they will be sick. So I think in our case, I say parasite infection did not affect performance of our pigs, but doesn't mean that's the case for all pigs.
Okay. Can you speak about why organic pigs have such a high rate of piglet mortality compared to conventional pigs?
That's the major reason is the housing. You know, uh, for organic pig production, no confinement is a requirement, which means gestating cells and farrowing cells have to be housed in open pen. And when the cells are not confined and they just lie down in where they want, and the piglets are at danger, at risk. So they basically crash on their they lay on their piglets to kill them that way. So that's a major reason. And right now in Europe, furring crates are kind of banned there, and they have a lot of pen furring, and they also see increase in pig mortality. So it's not only organic pig production. As long as you use no confinement housing system, you probably see higher breeding mortality.
Okay, so they're getting crushed. Are there any insect pests that are a problem in organic pig production?
Uh, that's a good question. I, we haven't seen any insect, in fact. So from ourselves and from the farms we visited, and actually, I think we were talking with a professor of pathology, pestologist at Kunshan University. They were talking about beetles may eat uh, asparagus eggs. And if we have beetles in the barn or in the pasture, we may see a reduction in asparagus.
Hmm.
So, you know, and so that's a good thing. That's a bad thing. So I haven't, no, insects, I haven't heard anything
Oh, that's
there.
interesting. So what kind of beetles were they?
I don't know.
Oh, okay. Yeah, no, that's very interesting.
Yeah, it is.
Okay. So, did any of the hogs in the parasite study have diatomaceous earth included in their feed rations?
No,
No.
no.
Okay.
And that's another thing I think we are very interested in. We heard a lot of different kind of remedies, say apple cider vinegar or, you know, may pumpkin seeds or whatever may help uh, deworm the parasites in organic pigs. We, I think I'm interested in testing the efficacy of any, alternative dewormers. So, but I know farmers use different kind of things, and when we visited them, we collect samples from their pigs and we see parasites. So, which means it's probably not that effective. But we haven't really tried. We probably should, and then show you the data rather than just by, you know.
Let's see. So I don't see any more questions. So I'd just like to thank everybody for joining us today. And thank you again, Yucha, for giving this presentation. And like I said, the recording will be available on the eOrganic YouTube channel within the coming week. So if you'd like to share that with anyone else, or if you'd like to view something again, it'll be there for you. So thanks everyone for coming and have a good rest of the day.
Thank you.